So we are continuing our discussion on central force motion, and we arrived at a very important equation, and now we have to solve this equation. Okay, so let me write this equation in terms of alpha. I mean, let me put alpha by r in v by r. So what do I get? I get 1 by r square. Let me write it down. Okay, so remember what was our idea? Our main plan was r as a function of theta. This will tell us what is the how will the orbit look. This will give the entire trajectory of the orbit. Okay, so we have to approach this very trickily. This equation looks big, so what we'll do is we'll try to make it small. So there are various tricks in theoretical physics that you will enjoy. So one of the trick is to make this equation small is assume 1 by r equals to y. You might have done this a lot, the substitution in your integration. This makes the equation looks easier. So what happens when I'll do d by d theta of 1 by r? Okay, so you'll get what? You'll get minus 1 by r square dr by d theta. Dr by d theta. Okay, so we'll implement this in our equation. So what do we get? So let me change the color. So from here we'll get dy divided by d theta whole square. Why? Because you see this is what 1 by r is y, and we have this 1 by r square dr by d theta already here, and square will take out the minus and will become plus. Agreed? So it becomes smaller. Let us look further steps. In the further steps, here you'll get a minus y square. Why minus y square? Because of this 1 by r square. And then you have a plus the last term, that will be 2m alpha divided by L square. Agreed till this? There is a 1 by r, so put the y here. Remember this 1 by r is y. And then finally we'll have the final term, that is 2me. So this is the first term. Okay, the final term is the first term. So 2me divided by L square. Okay, now one more trick. The one more interesting trick is we'll make this part simpler. We'll make the this part, we'll try to make it simple. So let us see how. So write dy by d theta as it is. So dy divided by d theta whole square as it is. And now I'm going to write something. If you expand that and solve it, you'll get this again. Okay, so let me write the expansion. So you'll get a minus of bracket y minus m alpha divided by L square whole square plus 2m e, agreed, divided by L square, and the last term will be a plus m alpha divided by L square whole square. So how did I do it? Okay, because if you expand this particular term, then this will get cancelled. Okay, it's very easy. I hope you get it. I don't have to teach a lot. Trick again, equation looks big, so one more trick, make one more substitution. Say z equals to y minus m alpha divided by L square. So make it another substitution. If you make another substitution, what happens now? Dz divided by d theta will be equal to dy divided by d theta. Why? because when you do the derivative with respect to theta, remember that this part is a constant part. Okay, so that will become 0. So now the entire equation can be written. Now I'm changing color. So after each trick, I'm changing a color. Okay, so now what happens, the entire equation becomes dz divided by d theta whole square equals minus z square plus b square. Now let's say from where b came. Okay, b was just a definition, where b is m alpha by L square into root over of 1 plus 2e L square 2e L square. So L is angular momentum, E is the total energy. Okay, so 2e L square divided by m alpha square. Okay, don't you see that the equation has become so simple? The equation looks so simple. Okay, so now there is no more trick, little bit of algebraic manipulation. So you'll get dz by d theta whole square plus z square equals to b square. Okay, this step is clear. This is, don't you feel like this is like can you tell me what will be z so that this is true? Let us guess. Let z equals to b cos theta. Okay, let us see if b cos theta satisfies this equation or not. Let us see. Okay, so the first term in this equation is dz by d theta whole square. So dz by d theta, I guess, will be b sine theta with a minus sign whole square, plus again we have b square cos square theta. So if you solve this, you'll get b square, the same b square that you have this side. So, well, amazing. Z is equals to b cos theta is actually satisfying this equation. Agreed? So now what? Now that we have got the solution of this equation, that is z is equals to b cos theta. Okay, so the work is not done yet. Okay, now we have to go reverse. So what is the reverse part? From z we have to go to y, and from y we have to go to r. Okay, so from z, let me directly write okay, so what was z? Remember z. So put the value of z in terms of r. So z is what? Y minus m alpha by L square. So y is what? 1 by r minus m alpha by L square. Agreed? I have just put z in terms of y and y in terms of r, and this side I'll have b cos theta. And you know what b is? B is this big term here. And then when you solve this, okay, let me write the result, the main result. When you solve this and put the value of b, a little bit of more algebraic manipulation, you'll get 1 by r equals m alpha divided by L square, okay, into 1 plus epsilon cos theta. Okay, so this is the main equation. This is the final equation that says how r will look in terms of theta. Don't you see, this is an expression where r is in terms of theta. One side we have r and the other side we have all in terms of theta. Now you would say, what is epsilon? Okay, so let me write what epsilon is. So epsilon is the small part of here. So this part, this part inside the B, this part has been written as epsilon, just to make things short. Okay, so what is epsilon? Let me write it below. So epsilon equals to root over of 1 plus 2 EL square divided by M alpha square. Okay, so we have reached our equation. This is the equation. This is the main equation. Let me put another bracket to make you understand that this is the most important equation. So what is this equation? This equation is the solution of this equation. Remember that all these tricks that we have played in between, introducing the value y, introducing the value z, all these tricks was done to solve this particular equation. And the solution of this particular equation was the idea to solve this particular equation was to get a expression that gives r in terms of theta, and we do have an expression. So let me rub the board. Okay, I hope you have written this one. So if you have copied down, and you can see that we have solved it completely. Okay, and we do have an expression. So this, so we solved this equation, this big equation, and our aim was to find r as a function of theta. We employed various tricks and finally we reached here. Finally we found what we needed. We found this equation, and this equation will tell you the various orbits that will happen when there is a central force. There can be circular orbit, there can be elliptical orbit. All the information are encoded in this equation. So in the next class we'll discuss more about various orbits in central force motion.